Hi guys. Okay, let me get to my spot and then I'll explain things. Okay, so this is our very first lecture video. I'm a little bit nervous. I would like to say that this is the very first time that I've done it, but the truth is that I did it earlier today, and instead of recording a video, I took 2 really lousy pictures. Yeah, we're not going to talk about that. Everything's learning, and I did learn to make sure that it is on video. Okay, so some things have changed. This is my front porch. You guys know my Draven. She's going to be assisting me today because I don't have an easel, though I'm going to try to work on that because I don't want you guys to have to... No, I don't want her to have to deal with this all the time. And my mom's not much better, and, well, y'all know Mr. Jackson. He would just mess up the lecture in the best way. In the best way. You know I love my man. So some things have changed, some things haven't changed. I got my tea. Unfortunately, neither Flannel nor Babe nor 2J got to make it for me. I had to make it for myself. And I have to tell you, you guys do a much better job than I do. I have a candle. Its scent is anti-mosquito. Yes, not freedom. Not freedom, because we are not free right now, are we guys? No, not at all. Alright, and I am ready to lecture. So as far as it's going to go, I want you to have your book out and open, okay? So if you need to pause the video to go get your book, that's good. Go ahead and do it because we're going to be talking about the lecture and flipping through the book as we're talking about it. So pause the video now, go get your book. Okay, I hope you're back with your book. Hope you have your book. I want you to open to page 82. This is content that you do absolutely positively need to have as a foundation content. This is the last standard that we need to cover, and it happens to be my favorite standard because it starts talking about genetics. And you guys love genetics, even if you don't know that you love it. You actually really do love it because everybody wants to know more about themselves. And then they look at their parents. And then, hopefully not you guys at this point, look at offsprings. It is really, really, really neat, but we have to have some super foundational understanding of what cellular division is before we can understand about genetics and how your DNA can separate out. So you got to get this down before we can move on. So today, or this week, we're covering mitosis. Next week, we're covering meiosis, or meiosis, depending on how you want to say it. I've posted an Amoeba Sisters video on mitosis. Please watch it as many times as you want to in order to feel good about the content. You can ask me questions while or on Google Classroom, and I will respond to them because I'll be making a video later on this week responding to the questions and also doing a little hands-on activity for you to watch, like a demonstration, I guess is really what it is, so you can understand mitosis just a little bit more so we can grasp it in 2 different directions. Ask me the questions. I will give you answers later. If you feel like sharing, do it on Google Classroom, but if you overshare, you will be muted. You know, standard rules apply. Okay, let's not go off on too many tangents. We got to keep the stream clean so that we actually have content. After we're done with this, though, then we can go back and review all of the other content that you might want to cover again or touch base on or anything that you have questions on. Okay? All right. So let's get started. Your book is open to page 82. This is Chapter 3, Lesson 1. We're talking about mitosis, which is how a cell divides. On page 82, they're asking a question, or some questions, 3 questions about this chick that they're showing in the egg. No, I don't know how they got that image, but it is pretty cool, right? Yep. And I mean, the chick's all wet and gooey, and so that's really the way it should be. It's a pretty darn cool picture. But they're asking, how did the original cell change over time? Okay, so the original cell is a cell that you're familiar with, the yolk and the albumin, or the egg white, okay, and you crack it open and it's all gooey. Okay, that was the original cell. How did it change to become a chicken? Well, we have touched base on this concept all year round, about the idea of growth coming from cells dividing. Okay, I want you to think about that as we conduct the rest of this lesson and try to tie it all in together. Question 2, what might have happened to the chick's cell as the chicks grew? Okay, did the cells get bigger or... That's right, Keb, they multiplied. Yep. Okay, so then how can one cell become a multicellular chick? I need you guys to go back up a few lessons and remember when we talked about cell differentiation. Okay, and think about when we talked about how you have two haploid cells that come together and create a diploid cell. Okay, so you've got the egg and the sperm. They join together, they make one host cell. And then they go through rapid multiplying until they become a blastocyst. After they become a blastocyst, it starts separating out into the 3 different layers. Okay, that's differentiation. I want you guys to remember that. Let's talk about the getting ready to read. We started doing this towards the end of our actual in-class time, so you should be familiar with it. What I want you to do is tell me if you agree or disagree, and you don't have to tell me on the Google feed. This is really actually for you. So if you've got your notebook, you can write it down if you agree to one or disagree to one. There's 6 statements, and you have to say if you agree or disagree. Then when you're done with the lesson and you're doing the lesson review, I want you to go back and see if you've changed your mind about any of those. So cell division produces 2 identical cells. Agree or disagree? Cell division is important for growth. At the end of the cell cycle, the original cell no longer exists. That one is the one that everybody, or not everybody, but a lot of people really get stuck on. There's a stump to that. And so I want you to make sure that you really feel comfortable with that information after we're done at the end of the chapter. Don't ask me right now. Put your hand down. Put your hand down. Don't ask me right now. We're going to cover it a little bit later. Okay? Great. 5. All the cells in a multicellular organism are the same. Okay? So we just want to know, is your eye cell the same as your epidermal cell, the same as your fat cell, the same as your toenail? Are they the same? We know that. We don't want a toenail growing on our tongue. Be uncomfortable. And 6, some organisms work together as part of an organ system. Well, we were doing organ systems, and we know a little bit about that. Remember, it goes cell, tissue, organ, organ system. There's that buildup. Okay. Let's flip the page and let's talk about your vocabulary words. You do have a vocabulary assignment and you do have a vocabulary test. No, you do not have to take the vocabulary test without your book. Yes, you can use your book. If you want to do, no, you do not have assigned DOKs, okay? You can just do what you need to do. If you have a DOK that you like, that you feel is effective in helping you learn the vocabulary words, do it. That's what we've been building up for this whole year, is you learning how to study independently, because this is really going to benefit you the rest of your life. So, vocabulary, I'm going to say them out loud to you so that way you can have the sound in your head, okay? Cell cycle, no big. Interphase, sister chromatid, centromere, mitosis, cytokinesis, one of my favorite words to say. It's so fun. Say it. Cytokinesis. Ooh. And daughter cell. Okay? There is a brain pop video that I will also post that will help with the vocabulary, and it's a little fun. Not mandatory, just a little extra. You do not have to do it, but if you're bored and you need to get out of chores, you could do it. Alright? Alright. Let us first I want us to turn to page 86 because I want you to be able to refer to the visual check, the figure 2 on page 86, where it talks about cell cycle. So cell cycle has certain set phases. Just like as a human, you start off as a fetus, and then you're an embryo, then a fetus, then an infant, and then a toddler, and then a tween, and then a teen, and a young adult, and then an old adult, or an adult, and then an old adult, and then you're geriatric, and then you're dead, right? Well, that's the way it's supposed to go. Well, cell cycles work in the same manner. They all have set stages and set phases. So the very first phase that a cell, that we talk about with a cell, if my easel will please hold this up, is interphase. I for interphase. Okay, interphase is the time that the cell is in the longest, so the longest stage of its life. Okay, there's a lot that goes on during interphase, but it's not a lot of busy happening stuff. Most of the cell's life is spent in the interphase cycle. So right here, and right here, this is all interphase. Mitosis is only an extremely small sliver of time that the cell spends in interphase. So here you've got half of the cell's life preparing for growth and rapidly reproducing its organelles. Then you've got your DNA replication that occurs in this time, and then you've got where it gets real nice and fat before it goes into mitosis. There are some things that you really do want to make sure that you know and understand about interphase. And if you look on page 86, you've got some bullets there. You've got rapid growth of the cell. So the cell spends a lot of time being itself and growing. Basically, it gets real fat. Yeah, I'm in interphase. Quarantine interphase too. Ooh, all right. And then it prepares for replication by replicating its DNA. That's really, really a complicated process that you are not going to have to learn this time. When you get into high school, you'll be looking at that at a deeper level. Right now, you need to understand just those basic phases that it goes through and the basic entrance as to what happens. So we're kissing cell cycling, and then we're going to leave it be. If you have more questions or you want to go more in depth to it, we can see about that, but let's first get our foundation. Then we've got the prepping for division. There's a lot of stuff that goes on in the prepping for division, but again, that's not something that you really have to know about, but I want you to know that your G1, your S, and your G2 are all phases of interphase. Then you've got this tiny little sliver of time that the cell spends in mitosis. Okay? Now, when the cell is not being replicated, it is called chromatin. That's when it's in its relaxed state. It's very chill, loose. It is so happy just to be itself. And if you look at a cell underneath the microscope and you scan for the DNA, you'll see that the whole nucleus just looks like a big cloud of mess, just a big bowl of spaghetti. It's hard to differentiate which chromosome and which chromatin goes with what, because it's all tangled up and just relaxed. But when the DNA replicates, when it goes through S phase or synthesis phase, it condenses down and pulls itself together into a tight little X that you've seen, that you recognize. This phase of the chromatin is actually called the chromosomes. Chromo being DNA, somes being body. Okay? We often depict it as an X with a dot in the center, but it's not really an X. It's better if you look at it as two sideways V's attached by that little dot in the center. That helps you to understand when the separation occurs, how it occurs, and how the copies are actually made. When it's in chromosome form, you have what's called sister chromatids. So if you were to cut it in half, it's symmetrical. And this half is exactly like this half, almost mirror images of each other. Those are duplicated chromosomes, sister chromatids. So this is a chromatid, and this is a chromatid. Together it's a chromosome. These are sister chromatids. You know biologists love to overlabel everything. This here is called a centromere. Centromere. Okay? All right, so that is interphase. Interphase. Do some of you recognize this I? Huh? Okay. All right. After the cell has gotten done with its DNA replication and it's ready to go ahead and divide, it's going to go into mitosis. Mitosis is separated into phases that we call PMAT. PMAT because it's easy to remember. Remember, we always want to have some sort of, ooh, what is that word, guys? Mnemonic. There you go. Good. Yeah, I heard you. Mnemonic, to help us remember the phases of everything, because there's so many different things in biology. that have so many definitely set words. So PMAT, P-M-A-T, okay? That is the bulk of the stages that happen in very rapid succession for mitosis. So PMAT put all together is mitosis. So if you are looking at your book, I would like you to please turn to page 90. Okay? Page 90 has the good images. I drew some images. Stop it. Leave me alone. Don't judge my art. All right. So mitosis begins with PMAT. PMAT prophase. First step of mitosis is prophase. This is when you get the copies of the chromatin and the DNA starts hanging out together and clumping together. They get to hang out. Your DNA gets to hang out with each other. We don't. No hanging out here. Okay? So what you have is you've got your cellular membrane that's still in perfect tact. You've got the cell that is growing faster and faster. You have the centromeres that are forming out here that are holding on to the spindle fibers. And you have the nuclear envelope that's starting to disappear. So remember that with eukaryotic cells, you've got a nuclear envelope and all of your organelles are in its own separate membrane. When it comes time for interphase, that nuclear envelope disappears so that the chromosomes are all out within the cytoplasm of the cell. The other organelles membranes do not disappear, okay? But the nuclear envelope does. This is important because what the cell needs in order to replicate is inside the nucleus. The whole reason why that those chromosomes and the chromatin have closed down and made these little X things is so that way they can accurately and evenly split amongst the two cells. So you're going to go, you've got replication in PMAT, so you got prophase, 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 okay? Yeah, I'm going to dance, and we're going to put it all together at the end, and you're going to do it, all right? In fact, if you do it, I might post it on Instagram. Maybe, if you send it to me. Okay, after prophase, we have metaphase. This is the second step. Okay? Nitra, hold it.
Why not? Oh.
Yeah.
Oh.
Thank you. Okay, so the second step is metaphase. Metaphase is the phase where you've got everything set and ready, but you need to get your ducks in a row. You need to line up your DNA so that way you can make sure that everything gets separated correctly. So metaphase stands for middle, or for the metaphyseal plate. The metaphyseal plate is that middle plate in which the DNA naturally aligns itself. Okay, and it does put the chromosomes within their X or their X formation onto that middle line. Okay, so it looks very, very much like this. And the book has a beautiful image of metaphase under the 250X. Okay, you've got your cell membrane intact, the nuclear envelope is gone. Spindle fibers are now formed, and you've got all of your chromatins lined up right in the middle on the metaphyseal plate. Okay, this is, like I said, really important because as we try to separate out and make two identical cells, we need to make sure that we have the information exactly in line where it's supposed to be. So we went from prophase down to metaphase, okay, lined up in the middle. All right? All right, so prophase and metaphase are typically easy for people to remember. Where they start getting tripped up is anaphase, but I'm going to tell you how I remember anaphase. Step 3 is anaphase, okay? This is the breakup. So when I was in high school, I was dating a guy who shall remain nameless because I don't want this video to get out and for him to be insulted. But he had an ex-girlfriend named Anna. And no, I'm not making this up. This is real life story, okay? Now, I didn't really truly like this guy very much at all. In fact, he really, really, really was not a good match for me. However, I really didn't like Anna, and Anna really liked the guy. So, because I was evil and wicked, and I strongly suggest that nobody follow in my footsteps, I made sure that the boy and I stayed together just so Anna couldn't get him back. But let me tell you, she tried. She tried over and over and over again. And anaphase is our breakup spot. So Anna tried desperately to tear us apart. So we're here in prophase, but now those spindle fibers are ratcheting and pulling it apart. It is the breakup, okay? Anaphase. Anna, oh, that wicked girl. But I won. Whatever, doesn't matter. All right, so anaphase is when you've got the spindle fibers that have connected to the centromeres, and they are pulling away the chromatids to either side of the cell, okay? The breakup. So we got prophase, 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 metaphase, 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 anaphase, anaphase, anaphase. Next, stop, is T for P-met. This is telophase. Telophase is the step where they are still connected, but they start to have a lot of distance between them, so they got to use the telly to talk. So they're in social distancing. Yes, the telophase is the social distancing of the cell cycle. Okay, and it looks something like this. I know y'all love my art. You've got the cell that is starting to pinch off, okay? And this area right here is called the cleavage furrow. You have the nuclear envelope that is starting to reform around the chromosomes, which are starting to relax, okay? You have the organelles that are separating out into their separate spots, but the DNA that's in each of these nucleus is absolutely positively identical, and that is extremely important. You got to know that. The spindle fibers are disappearing, and the cell's ready to break up with itself. It's ready. Telephone might not work so well. That moves us in to the very last phase, which doesn't have its own word. So we've gone from prophase, 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 metaphase, 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 anaphase, 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 telophase, 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 and we end with cytokinesis. Okay? Cytokinesis is when the breakup is finished. It's over, it's complete. You've got two identical cells. Okay, you got to remember that. Two identical cells that we call daughter cells. Two daughter cells. Okay, so you do not have the original and its daughter. You've got two daughter cells. Don't ask me why science named it like this. That's just the way they named it, and that's the way you got to learn it, because that's life. No. I'm sure there is really good reason behind it, but I'm sure that the lecture on the good reason behind it will take a lot longer, and I think we're almost all done. Okay? So all of the organelles that were in the original cell are in both daughter cells. All of the DNA that was in the original cell are in both daughter cells. That nuclear envelope is back to being formed. The two cell membranes have formed, and the cells are all alone. Nobody's with them. Actually, they're probably most likely with other cells like them that are creating the tissue that is creating the organ that is going into the organ system. But this is cytokinesis. So we have interphase and then PMAT. Sorry, y'all. Prophase, metaphase, anaphase, telophase, cytokinesis. I sure hope that you can read that. Okay, so again, the dance. Prophase, 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 metaphase, 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 anaphase, 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 telophase, telophase, cytokinesis. That's right. And like I said, you videotape yourself doing that and send it to me, and I may, no promises, but I may put you on Instagram. You might become Insta-famous. I never keep any of my food or drinks, do I, guys? Nope, never. I love you all. I miss you all. Email me your questions or post your questions or do what you need to do in order to get me the questions or get your questions to me. Make sure that you read the book. It's really, really good. I'm going to post a couple of other informational videos. There's this video that they have of a time-lapse of cells dividing, and it is beautiful. And if you look close, you can see when they're going through anaphase, there's like this one set of chromosomes that's like, no, don't leave me. It's awesome. Okay, I'll post that one up as well. You don't have to watch it. You don't have to do it. Remember, this is an educational opportunity that is all for you. You are getting to get a PhD quality education for free and at home in your jammies. Please, please, wash your hands and shower. Love you guys. Talk to you later. Bye-bye.
And if I ever run into that anaphase and her boyfriend, it's on.
Bye, guys.